We're now going to look at the derivative of an inverse trigonometric function. So we're going to compute the derivative of the arc cosine. To do this, we'll use implicit differentiation. So how to do this? Well, the point is here that if we put y equals to arc cosine x, this is by definition the same thing as saying that the cosine of y is equal to x. Well, granted that x is in the domain of our cosine and that y is in the range of our cosine. This we're given from the start, so this is just reminding ourselves so that we're not tempted to put anything else inside of the cosine, who's defined, of course, for more y's than just this. And how to use implicit differentiation. Well, now here, the point is to realize that y is a function of x. So here we don't need to pretend that we actually know this. And then we differentiate implicitly. So let's perhaps just write this. I'm really not doing anything in this between these lines. Now, if the left-hand side here is equal to the right-hand side, then the derivative of the left-hand side is equal to the derivative of the right-hand side. Well, what is the derivative of cosine? Well, it's minus sine. So this is the outer function. So minus sine of whatever's inside of this is the outer derivative. So let's do this. And who's the inner derivative? Well, it's just y prime x. And who's the derivative of the right-hand side? Well, it's just 1. I differentiate x with respect to x. And this is equivalent. And if I now solve for y prime, what do I get? Well, I get y prime x is equal to minus 1 over sine y prime x. And who's y? Well, it's the arc cosine. So 1 over the arc cosine of x, like this. Let me write this here, but this of course requires x to be such that this thing here is non-zero. So I'll put a caveat here like this, and I'll leave it for you to check, okay, when does that happen? Now, so for all x such that this isn't 0, this is an expression for the derivative. For x such that this is 0, then the derivative actually does not exist. And how to simplify this? Here you can use geometry, or you can use the Pythagorean identity, or you can go, we've actually computed this earlier in the course, but let's do it by hand here. So here we have what? So notice that sine of u to the square plus cosine of u to the square is always equal to 1. So if I put arc cosine here inside, this plus this is 1. But of course, if you take cosine of the arc cosine to the square, this just gives you x to the square. So sine squared of arc cosine, x is equal to 1 minus x squared. This means that sine of arc cosine x is equal to either plus or minus 1 minus x squared. And then you can notice that, so what does arc cosine give me? Well, it gives me numbers, outputs instead of 0 to pi. What happens when sine takes input between 0 and pi? Well, sine looks like this, right? So here's 0, here's pi. So it only takes positive output there. So it's this thing here, okay? So this means I'm getting here minus, and then I'm getting this thing. So this is the derivative of the arc cosine. So remember, y is the arc cosine. So y prime is nothing but this derivative here. And we're done.